and welcome to SOLIDWORKS Skills video.
In this video I'll be demonstrating how to add a belt, like a timing belt, to an existing machine. This happens to be a 3D printer. The method I'll be showing is applicable both to chains and belts. Alright, so let's get started. I have a series of pulleys, each one at the base of a lead screw. Got 1, 2, 3, 4. Plus I have a motor and a tensioning idler. Formerly, when I wanted to add a belt using a very manual method, I would create a sketch. I would convert entities out to each pulley, do tangent lines and so on. It was a long drawn out process and not particularly easy. Thanks to Paul Gwinnett, the TA in our junior projects class, I've become aware of this very nice feature. I'm not sure when it came into SOLIDWORKS, but it is there now in the 2016 version. So let's go ahead. I'm going to create a belt, a timing belt, that traverses this entire path, and then you'll see how I can adjust the length. I can measure the length, I can move the tensioner and have it automatically compensate. So it's an assembly feature. So up on the menu bar you'll see assembly features. Go down to the bottom where it says belt and chain. And now it's wanting me to add what it calls belt members. In this context that means the pulleys. So I'm going to go to the first pulley and I'll click on the face of one of the pulleys. It creates a circumferential line in yellow. I'll go to the next one. Now you must track around in proper sequence, otherwise SOLIDWORKS won't know where the belt goes from and to. So I'll go to the next pulley. You can see it's already created the beginnings of that belt. It's right now a very simple path. Let's add more elements to it. I'll go over to the next pulley, zoom in, click on the face. So now it's got a three-way belt system. Go to the next one, go to the fourth. We're most of the way there. Now I need to add the motor, the drive motor, to this. It has its own pulley. Click on that. So the only thing left to do really is to add the tensioning idler, which is over here, and you'll see, I'll do it, and you'll see how SOLIDWORKS takes its best guess at it. It happens that's not how a belt works, but I do have the opportunity with this arrow to change the path to be more appropriate. So now I have the entire sketch of the belt travel. I do want to use a belt thickness. This will offset it a little bit from that face. My belt happens to be 0.03 inches thick, and I do not want to engage the belt. What the engage belt function, you may find this useful for animations. It allows you to turn one of the pulleys and have the belt actually appear to travel and drive the other pulleys. I'm not going to have that in this instance, but I do want it to create a belt part. That's a brand new part. So I'll click on that, and I think I have selected everything that I need. So I'll let it go ahead and do that. And what it will create is a sketch of the path. It's not actually creating any solids yet, but I can go in and confirm that the sketch, sure enough, does follow the path. The desired path goes from pulley to pulley. There's nothing looped backwards. And so let's go down and look in the feature tree, and you'll see that this belt, this assembly feature, shows up at the very bottom. If I click on the right facing arrow, there's the actual part. This is belt 3. I can rename it. I'm going to do that right now. I'm going to rename the part to, I'll call this a Z-axis belt, and there it is named. Let's add some beef to it. Right now it's still just a disembodied sketch. So I will right click on this, go to edit part, and like with any part editing, I can add features, sketches, and whatever makes sense. So in this case I want to extrude with that line. I will select the line itself. It'll use the entire path. Now the initial extrude, like one would expect, would be this weirdly shaped solid. No, what I really want is a thin feature where it uses that line and will create a thin extrusion that follows the path of that line. The thickness is okay at 0.04 inches. I think it copied that over from the creation. However, the extrusion itself, notice it's extruding up from the line. I want to use instead a mid-plane, and I want to add the appropriate width of the belt, which happens to be 6 millimeters. You'd use whatever the belt you have instead. So there I am with a thin feature. It's 0.04 inches thick, and it follows the path of that line. I will accept this, and there is my belt. I will exit the editing of this part, and now it's shown up live in the assembly. Remember I mentioned that I have an idler, a tensioning idler here. I will move that and you'll see what happens. I'll move the tensioning idler, and initially the belt seems to not follow. That's not a problem. I'll go up to the rebuild icon way at the very top here, and it will re-establish a connection because I've told it when it created the belt that this pulley is part of the path. Okay, so this allows me then, I can go back down, look at the belt, and it shows me the length right here of 92 and a little bit more, almost 92.25 inches. And then I go and start doing some shopping, and I find that there's a convenient belt. I'm going to bring one in here now as a convenient belt that happens to be 2460 millimeters, and you can run the numbers. That's a little longer, but you can't necessarily buy a stock belt with every possible teeth count. You have to find the ones that are available. This one, because I've already checked it, is a little long, and that's okay because you'll see how it takes up for it. So I'll go back into the belt. I'll right click on that, edit the feature. Remember I had a length of 2,460 millimeters. I will say that the belt length is driving the design. So I will type in 2460 millimeters. I will accept that, and you'll see it takes a moment to calculate, but it did the job. It moved the tensioner as necessary. It shows me the new belt length, and I consider this an absolute boon because it makes it so much easier not only to draw the belt in place, but to determine what stock belt or what you should buy to complete the assembly.
Thank you for watching. This video is part of a series created by Neil Rosenberg and Joseph Caswell. All rights reserved.